Right, so this is another question on probability, and this time it's on independence of events. So what we have a dice, right? So let me just draw a dice real quick. Yep. And it's got a 1 over here, and this is kind of what a dice looks like, right? And what we're told is this dice is rolled twice. It's rolled once, and we get a number x, right? So you can get a number between 1 and 6 on a dice. So you roll the dice once and you get something, and let's call it x. So this is on the first roll. And then you roll it again and you get a y. So this is what you get on the second roll. And two events are defined, A and B, and A is the event, let me just write that again, A is the event such that the pair of numbers that you get, x and y, for the two rolls, they add up to 11. So you get something on the first roll of the dice. So let's suppose you get a 3, and you get something else on the second roll of the dice, and let's say that's 2. So you just add up 3 plus 2, right? And whatever number you get. So 3 plus 2 does not add up to 11, but what you're supposed to do is just add up what you get on the first and the second roll of the dice. And the second event, B, is very simple. It's the all sets of events where you actually don't get a 5 on the first roll, right? So it's all x and y where x is not equal to 5, right? So B is simple. Just don't get a 5 on the first roll. And what we're being asked is, are A and B independent? So that's the question that we are being asked, right? So let's see, how do we go about thinking about this problem? So well, this is kind of mathematical notation, but I would really want to see what the what kinds of outcomes will make up A and B. So I want to see what A and B look like. So what does A look like, right? So A is going to be made up of sets um, like like x1, y1, and x2, y2, and things like that. And they have to satisfy the condition that x plus y is equal to 11. So let's think about this. So if what you get on the first roll, which is x, if that's 1, then is there any way you could satisfy the condition for A? Well, if you get a 1 on the first roll, then you will need a 10 on the second roll to satisfy A. And that's not possible. The largest number you can get on a dice roll is 6. Could you get a 2? Well, no, 2 is also not good enough because you would need a 9 then. Could you get a 3? Well, 3 is also not good enough because then you would need an 8. So if you really think about this, the minimum that you need on the first roll is a 5. Because if you get a 5, then you just might get a 6 on the second roll, and then you could satisfy this condition. So 5 plus 6 is 11. So, but the minimum you need is 5. And you could, if you got a 6 on the first roll, then yes, you might get a 5 on the second roll, and then also you would satisfy. But other than these two, there really isn't much, there aren't many combinations that would satisfy A. So A is simply the following two pairs. It's 5 by 6, 5 comma 6, and 6 comma 5. The only two pairs that satisfy A. What about B? Well, B was simple. B was simply that don't get a 5 on the first roll. So which means that something like 1 comma 1 is okay, and something like 1 comma 2 is okay, and 1 comma 3 is okay. So all the way up to 1 comma 6, and anything starting with a 2, that's also okay, and anything starting with a 3 is okay. 4, fine. You can't get a 5 though on the first roll, but yeah, 6 is also okay. So a very big set of events that would a very big set of favorable outcomes for B, right? So B is all of these events. So now the question is, are these two events independent, right? So what's the condition for independence? So I'm just going to section out this area a little bit, just make it a little cleaner. So what's the condition for independence? Well, if A and B are independent, then the probability of A given B should be equal to the probability of A, right? And this is not just a mathematical statement, really. There is some intuition behind this. Well, basically what this means is uh, you, the fact that B has happened does not affect the chances of A happening if they are independent. If A and B are independent, then the fact that B has happened, so let me just write this down. Uh, the fact that B has happened does not affect the probability of A happening. So A is just as likely or unlikely to happen irrespective of whether B has happened. So that's when they are independent. So if this condition is true, um, then yes, they are independent. The two events are independent. And if this is not true, then they're not independent. So what we'll be looking to do is finding values for P, A given B and probability of A, and then we'll be just comparing those two values. So let's do that now. So let me do this on a fresh screen because I might need some space for this. So what is probability of A given B? Well, probability of A given B is simply probability of B given A multiplied by probability of A divided by probability of B, right? So we got three terms on the right hand side, and we'll need to find values for each one of them. So what about what's the probability of A equal to? So A was the event that x plus y has to be equal to 11. Well, if you roll the dice twice, then how many possible outcomes are there? Well, there's 6 possible outcomes in the first roll and 6 possible outcomes in the second roll. But as we said, A is only made up of these two elements, 5 comma 6 and 6 comma 5. These were the only two um, outcomes that are favorable to A. So we got only two possible favorable outcomes. So which means this is 2 divided by 36, which turns out to be 1 by 18. So probability of A happening is 1 by 18. What about probability of B? Well, B was simple. Just don't get a 5 on the first roll of the dice. So we have 6 possible outcomes for a roll of a dice, any number from 1 through 6, but but barring 5, anything else will go, right? Anything else is good for us. So that leaves 5 possible favorable outcomes, and therefore the probability of B happening is 5 by 6, right? So now we've got this term down and we've got this term down, which leaves us with just the finding out what probability of B given A is, right? So what does this mean in plain English? So A has happened, right? So that's a given. So we know that we've rolled the dice twice and we've got one of these two combinations, 5 comma 6 or 6 comma 5, right? Now the question is, what's the we don't so now what's the probability that B has also happened, right? So A is given, so we're down to these two combinations. So what's the probability B has happened? Well, B just said don't get a 5 on the first dice, so this is out. So that leaves only one favorable outcome. So we got two possible outcomes and only one of them is favorable. So which means the probability of B happening given A has happened is simply 1 by 2. So now we know everything in this expression to calculate probability of A given B. So probability of A given B is simply half multiplied by probability of A was 1 by 18 divided by 5 by 6. And this turns out to be 1 by 30, right? And how does this compare with probability of A? Well, probability of A was 1 by 18. So this was probability of A. And you'll notice it's not equal to the 1 by 30 that we calculated for probability of A given B. So what's the bottom line? So the bottom line is A and B are not independent, right? So that's the bottom line. But notice one other thing. It's not just that probability of A and B, A given B is not equal to probability of A. Notice that probability of A happening given that B has already happened is actually less than the probability of A happening, right? So the fact that B has happened, and B was the probability that the first roll of dice is not equal to 5. So if B happens, which means that you did not get a 5 on the first roll, well, that just makes the probability of x plus y being equal to 11 eventually that much less likely. So the probability of A actually falls if B has already happened before. So so this is interesting. You can take a step further and interpret the results um, uh, and see the reason why A and B are not independent. So so that was the question on probability, and that's how it's done.